Question says that a child stands at the center of the turntable with his two arms outstretched. The turntable is set rotating with an angular speed of 14 revolutions per minute. How much is the angular speed of the child if he folds his hand back and thereby reduces its moment of inertia to 2.5 times the initial value? Assume that the turntable rotates without friction. So the question is trying to say that there is a turntable like this. At first the kid is standing and he's stretching his hand, and in the second case what he does is he's still standing but he pulls back his hand and folds it. Now this is a turntable and it is rotating on the frictionless surface, so there is no any unbalanced force acting on this system of the turntable and the kid. So we have to find out what is the final angular velocity, angular speed, if the child folds his hand. So angular momentum would be conserved in this case, as there is no any external force acting, so there is no any friction. The system's angular momentum is going to be conserved, that is I1 omega 1, that is the moment of inertia initially multiplied with the angular speed in the first case would be equal to moment of inertia final and the angular speed in final case. Now substituting these values, we will get the final angular speed of 100 revolutions per minute. Now the question says that show that the child's new kinetic energy of rotation is more than the initial kinetic energy of rotation. How do you account for this increase in energy? So for finding what times does the final kinetic energy higher than the initial kinetic energy, we will take a ratio of initial and the final kinetic energy, and we find out that kinetic energy final is equals to 2.5 the kinetic energy initial. So kinetic energy final is greater than the kinetic energy initial by 2.5 times. Now the question is asking why is it so? So we see that since the system is not being acted upon by any unbalanced force, so the work done by the kid by folding his hand must be raising the angular speed of the turntable. So that is the reason why the angular speed final is greater than the angular speed initially. Thank you.